now look at the second kind of construction that we have in class 10th mathematics, and that is the construction of a triangle similar to a given triangle when the scale factor is given. Now, what is scale factor basically? For example, you have been given a triangle ABC and you've been told that you need to construct a triangle that has its sides for about 3/4 of the side of the given triangle. Then here you mean to say that the ratio between the sides of the smaller triangle to the bigger triangle is 3/4. So this ratio, which determines the proportion between the sides, is what we call the scale factor. And we are given the scale factor to actually construct the triangle which we need to construct, right? So the scale factor is very, very important here. So let us now try to understand how we construct a triangle similar to a given triangle with the use of an example. Why I'm taking examples is because if I take variables, it'll become very, very complicated. And that happens because if you read R.D. Sharma and NCERT, I'm not too sure if it's there, but in R.D. Sharma, they have given the procedure with variables. So some people are able to understand it, but some people actually get confused. So I want to take examples so that you understand it better, right? Then you can apply it to any given triangle you have. Now, let's try. If you see, let me take a triangle ABC. Suppose I've been given a triangle ABC where AB is equal to 4 centimeters, BC is equal to 5 centimeters, and AC is equal to 6 centimeters. Now, I want to construct a triangle similar to triangle ABC such that each of its sides is 2/3 of the corresponding sides of triangle ABC. So here, suppose the ratio I have been given, suppose the scale factor or the ratio between the sides of the similar triangle to the original triangle is 2/3. So here basically what happens? The scale factor becomes 2/3. So 2/3 is my scale factor in this question. So using the scale factor and using this given data of the triangle, I will be constructing a triangle similar to this given triangle ABC, right? So let us start. Now, first of all, we will be taking the construction and side by side I'll be writing the steps as well, right? So the steps will be here. And I'm going to side by side construct the triangle here, right? So suppose let me divide this page. So it'll become very easy now. So first of all, we are going to take this triangle ABC. First of all, we need to construct triangle ABC itself. So how do we construct triangle ABC? Well, take BC, the base, that is 5. So suppose my BC is 5. And with B as center and 4 centimeters as radius, because A is 4 centimeters away from it. So 4 centimeters as radius, I am going to cut an arc. So B as center and 4 centimeters radius, I'm going to cut an arc. And with C as center and 6 centimeters radius, I'm going to cut this arc which I have cut. So they meet at a point. This point is going to be A. So then we're going to join A to B and we're going to join A to C. Okay, we're going to join A to C. So this is going to be, let me write it properly. Oh gosh. I'm really, really sorry, but okay. So AC is joined. So AB is 4 and AC is 6. So with this, I've got my triangle, right? So that's absolutely clear. We've done that. The next thing I'm going to do, so first of all, let's write that as a step, that draw a triangle ABC and with the given sides, whatever, just write that down, right? Now the second thing we're going to do, we are going to make an acute angle at B with a ray BX. So we're going to make a ray BX. Suppose this is my BX and I'm going to make an acute angle. We are going to make BX as a ray such that it forms an acute angle with BC, right? So that's my next step. And on this BX, now basically what do we do when we construct a similar triangle? When we take a similar triangle, basically the angles of both the triangles will be equal, right? And their sides will be in a particular ratio which we have been given, 2/3. So we need to construct a triangle which has equal angles as this triangle, right? Equal corresponding angles, but the sides are at 2/3 ratio. So how do we do that? First of all, take 3 as, this number, right? 3, the denominator number. We are going to take this denominator number, or better say the bigger number between in the ratio. So sometimes the numerator is bigger, then take the numerator. If the denominator is bigger, take the denominator. But you need to take which is the bigger number in the scale factor. So the scale factor 3 is the bigger number. Take that number and cut that many number of arcs on bx, or on that ray you have taken, right? So I'm going to take 3 arcs on bx. Since the larger number in the scale factor is 3, I'm going to take 3 arcs on bx such that the distance between any 2 points formed in this ray will be equal, right? Like we did in the division of line segment. So we're going to take BS center and we're going to cut 3 arcs. So one arc is here. This will be my B1, and then same distance, and then B1 as center, cut here. This will be B2, and then B1, B2 as distance, and then B2 as center, cut the third last arc, which is B3, right? So that's what I'm going to do. Draw ray bx, or write like this, bx, and locate b1, b2 and b3 on it such that bb1 is equal to b1 b2 is equal to b2 b3. So this is going to be the thing, right? So this equal to this equal to this, right? I hope you understood that. Let me mark it with another color so it becomes easy. This equal to this equal to this, right? The next step, we are going to join B3 to C. So suppose I'm joining B3 to C. I've joined B3 to C. And we are going to construct a line because here numerator is 2. The other number is 2. So at B2, we are going to construct an angle equal to this particular angle which this B3C is forming with BX. So this B3C is forming this particular angle with BX, right? This angle. So we're going to construct the same angle at B2. So construct the same angle at B2 as we did in division of line segment. Take this PQ as the radius. After you construct this arc, take PQ as radius and this as center, this E as center. Then cut an arc, right? And then join this B2 to this arc and then take it till it reaches BC at some C dash. And here you can very well understand these two angles are equal, so these two are going to be parallel to each other. So basically I've constructed a line B2C dash parallel to B3C after joining B3C, right? So these two are going to be parallel to each other. Now that's my third step. The third step will be join B3C and construct B2C dash parallel to B3C, right? We know that by drawing similar angles, we're going to do that, and we're going to form a C dash here, right? That's my third step. Fourth step. Now I've got this point, that is the second point of the triangle. We already have this B common point, right? Now we have got the second point of the triangle C dash. Now we're going to make the last point. We need to locate the last point of the triangle that we need, and then we'll get the similar triangle, right? So that's what we're going to do. To locate that point, we now need to draw a line or a side parallel to AC, right? From C dash parallel to AC. Here we constructed parallel to B3C. Here we're going to construct parallel to AC from C dash. So for that, again, we're going to look into our angles, right? So this is going to be my angle here. Now suppose this is some R and this is some S, and I'm going to make a similar arc here, and then RS as radius and this point as center. We are going to cut an arc, right? Let me cut it somewhere else better. Construct an arc. Now the C dash I am going to join to this arc. I'm going to join to this arc and we are going to get our parallel side parallel to this side, right? And then you will see that it intersects AB at a point A dash, right? So you can see that in triangle A dash B C dash and ABC, angle B and equal to angle B common, then this angle and this angle are equal, and you know these two angles are equal definitely. So these two angles are equal because we have constructed them, these two parallel, so these two have to be equal by corresponding angle property, and then these two are also equal. Hence triangle A dash B C dash is similar to triangle ABC, and this shaded triangle is our required triangle similar to the given triangle, right? So I hope that's absolutely clear to you, right? So what did we do in the fourth step? In the fourth step, we basically construct A dash C dash parallel to AC by using corresponding angles. So this is the corresponding angle we're going to construct. These two will be parallel and these two angles will be equal. Then this meets AB at some A dash. So these two angles equal. This is a common angle. So it's an angle similar to that given triangle, right? And construct A dash C dash parallel to AC meeting AB at A dash, right? At A dash. Therefore, your triangle A dash B C dash is the required triangle, right? So in this way, we constructed a triangle similar to the given triangle with the given scale factor. Here the scale factor is important. I told you how we need to use the scale factor. Take the larger number, cut that number of arcs, and then the smaller number from that number, the last number, we are going to, usually what we basically do is we cut that number of arcs, the larger number of arcs, and then we are going to connect the denominator number position with the with that side. Okay, so for example, if this was well 4 by 3, here 4 is the larger number, right? So we're going to cut 4 arcs, but we are not going to connect B4 to C. No, because here the triangle we want, it is bigger than the original triangle, right? It is bigger than the original triangle. So we're going to connect B3 to C, right? B3 to C. And then we are going to construct a line parallel to B3C from B4, right? And that B4 is going to meet that parallel line from B4 is going to meet extended BC. So this BC will have to be extended, and then here it will meet somewhere. Then you see you'll get a bigger triangle than your original triangle, right? So that's a slight difference when the scale factor is greater than 1. Right? So when scale factor is greater than 1, the triangle you want will be bigger than the original triangle. Hence, a procedure will be slightly different. Right? So I hope that's absolutely clear to you. Right? Any kind of doubts? Most welcome in the comment section below. So with this, I have basically concluded my lecture on construction of a triangle similar to a given triangle. Right? So we are left with only one kind of construction in our course, that is construction of a pair of tangents similar to construction of a pair of tangents to a circle, and construction of one tangent also we will discuss, right? So I hope you're absolutely clear with this. If you have still any kind of doubt, please post it in the comment section below. Please leave a like, do subscribe, share, and best of luck for your examinations. Thank you and bye-bye.